Today we're going to be looking at the 5 pieces of evidence that scientists use for evolution. Keep in mind, the more similarities that organisms have between these pieces of evidence, the more closely related they are, or in other words, the earlier the split was in the tree of life. The more different they are, the later the split. Let's take a look at the pieces of evidence. Evidence for evolution. Remember, organisms come from existing species. What evidence is there for evolutions and species relationships? Organisms that have more similar features are said to be more closely related. People have always known that us and other organisms exist on the planet, but our relations to other organisms have always been in question. With evidence, we can also see, however, the relations between organisms, as well as how ancient organisms may have diversified or just existed on the planet. These are the evidence for evolution. What are the 5 pieces of evidence for evolution? Fossils. Bones, imprints, or other organic material that has been replaced by mineral are very old and allow us to look at similar features in organisms. When an organism dies, sometimes it's set in stone. The stone will gradually replace the organic material, creating an imprint or stone-like structure where bones and hard parts used to be. We see these bones now at a later time and rearrange them in the correct order based on living organisms. These fossils are very old and indicate that there was previous life on the planet before us that is no longer present. Biogeography. Organisms that look very similar are in different locations. Fossil evidence suggests a common ancestor migrated. Using fossil evidence, we can see that organisms have spread out throughout the globe. Oftentimes, we find intermediate species between these, or species in different areas. This suggests at some point a common ancestor migrated across an area. Another piece is that fossils are found on the opposite ends of the world. Identical organismal fossils have been found across the world. This suggests that at one time the continents were connected and the organisms wandered around. This both leads to it that organisms, as well as the world, has changed. Comparative anatomy examines bones and organ systems of animals. The more similar the structures, the more closely related the animals are. By looking at comparative anatomy, you see common trends within the bone structures of certain related animals. For example, in mammals, the hand part of the fibia, tibia, radius, ulna, carpals, and metacarpals are very similar. This indicates millions of years ago, there was a common ancestor that shared a very basic form of this structure. As natural selections and mutations occurred, the bones diversified, creating the range of species that we see today and in the past. Other examples are the thumbs on the chimpanzees, humans, and gibbons, as well as the wings within insects. Because these are all very similar, it's indicated that there was a common ancestor at some point. Vestigial structures. Structures that are found to be useless in organisms. Other organisms have identical structures, and they are quite useful. This suggests a common ancestor. An example is the appendix. Vestigial structures are structures that at one time had a use, but now no longer do. However, we see similar structures in other organisms that lead us to believe that they were used at some point. Because these structures are existent and have now lost their purpose, we say they are vestigial, no longer working, but indicate that the organism has changed over time. Genetic similarities. Compares DNA pairing. The more DNA in common, the more closely related the organisms. Remember, you get your DNA from your parents. So, if organisms have existed for a long time, the DNA has been copied and traded down from generation to generation. By comparing the similarities and differences in the DNA, we can see how closely related an organism is and how recently the split was on the tree of life. Now that you've seen this, how do you think our scientists use this information to be able to piece together the tree of life? Look forward to hearing our discussion tomorrow for it. Have a good one.